So here's what we're wanting to do today. It says I can use a scatter plot to describe the relationship between two data sets. So what two different data sets means, that means I have an X value and a Y value. Those are my two data sets. So for instance, some of the problems we're going to look at today are going to have time as the X and temperature as the Y. So those are two different data sets when we're comparing time and temperature. And then you see there we have 6 vocabulary words, but really the first 5 are all tied together. And we'll see them as we get into our first few examples. It says Nicholas plotted data points to represent the relationship between screen size and cost of a television set. Everything about the televisions is the same except for the screen size. So you can see here he had a 40-inch screen, cost $300. 42-inch screen cost $350. 43-inch was $400. 48-inch was $480, and 50-inch was $500. So describe any patterns that you see. So what kind of patterns do you guys see between that data? As what goes up? So yeah, so as the screen size in inches increases, the cost is also increasing. Right? Both are, as we go to the right, the price is increasing. So what does this set of points tell you about the relationship of screen size and cost of the television? So we just said it. What would the relationship be? The bigger the screen size, the more it costs, right? I mean, it's really that simple, what we're looking at today. So where do you think the point for a 46-inch TV would go on the graph? So if you had to put a spot here for 46 inches, about where do you think it would go on the graph?
About 450.
Right? It would be somewhere between 400 and 480, right? So 450 would be a good guess. Somewhere between 400 and 480. So if you put it at 450, that's fine. What about a 60-inch TV? Where do you think it would go? Okay, so that's a little harder to predict because we don't have anything to the right of it, right? But we do know that we could expect it to be more than 500, right? Because if a 50-inch was 500, we'd expect a 60-inch to be higher than that. All right, so let's look at our first example. Okay, it says, what is the relationship between the hours after sunrise X and the temperature Y shown in the scatter plot? So look, this is 0 hours after sunrise. This is what the temperature is. Now look, the more hours after sunrise, what's happening? The temperature is increasing. It's increasing pretty quickly. And then what kind of happens here? It kind of levels off, then it increases, and then it really starts to level off. But from the first 0 to 10 hours after sunrise, we're generally increasing. So it says, as the number of hours after sunrise increase, so does the temperature. When Y values tend to increase as X values increase, the two data sets have what we call a positive correlation. A positive association. So as one is increasing, then the other is increasing. That's called positive association. You may think that since the points do not line up exactly, there is no relationship. However, when looking at an association, we're just looking for a general trend. So it doesn't have to be exactly the same everywhere. We're just looking for a general trend throughout the entire graph. It's like as you look here, you can see, hey, the temperature is trending upward the entire time. So that has a positive association. B part says, what is the relationship between the hours after sunset and the temperature Y, shown in this scatter plot? Okay, so this time, as my hours after sunset is increasing, then the temperature is decreasing. So as the number of hours increases, the temperature is decreasing. So when the y values decrease as x values increase, then we say these have a negative association. Sorry, that should be highlighted. Negative association here. So as I look at this graph from left to right, it is decreasing over time. So again, that's a negative association. Any questions there? It says, how can the relationship between hours after sunrise X and temperature Y be modeled? So this is that same graph we were looking at earlier. Now let's read what it tells us. It says the data points on the scatter plot approximate a line. That means they're kind of close to a line. We sketch a trend line that best fits the data. So your book calls it trend lines. I've also seen line of best fit. So it uses both of those words there. Have you ever heard of line of best fit? Trend line, maybe, maybe not. Okay? This line is what best fits the data, and it helps us determine whether a linear function can model that relationship. So the trend line suggests that a linear function can model the relationship because you see how these dots are kind of along that line. So the scatter plot suggests a linear relationship. There is a positive correlation because it's going up from left to right. When data with a negative association is modeled with a line, there is a negative correlation. If the data does not have association, they cannot be modeled with a linear function. With a line. What do you think? I think I could see a line going through there. And that would be a negative correlation because it's trending downward. So now we're going to be finding equations for our trend lines, for our lines of best fit. So it says here, what trend line models the data in a scatter plot? So a trend line models the data in a scatter plot by showing the general direction of the data. A trend line fits the data as closely as possible. So step one, we're going to sketch a trend line for the data. So you can see out of all these dots, they have chosen this trend line. Okay, do y'all think that's a pretty good fit? I think it's pretty close, right? We're going up pretty quickly. Now it says a trend line approximates a balance of points above and below the line. So you see some of them are to the left of the line. That would be above the line. Some of them are to the right of the line, which would be below the line. So it's just kind of right in the middle of those to get our trend line. Now, once we find our trend line, to write the equation, we're going to have to use what's called point slope form. So, as you can see, look at this line. This line goes through 2 points. It goes through 250 and 16,500. Does everybody see those 2 points on our line? So, when we have 2 points, we are able to find the slope between those 2 points. So, do you guys remember the slope formula for a line? All right. What is it? Does anybody remember? Maybe not. It's y2 minus y1 over x2 minus x1. So what we're going to do is we're going to plug in these points into the slope formula. So I'm going to make this here my x2 and my y2, which is going to make this x1, y1. So when I plug in, I've got y2, which is 500, minus y1, which is 50, over x2, which is 16, minus x1, which is 2. That's what I plug in. That's going to be 450 divided by 14. And hopefully you've got a calculator to do that, because I don't want to do that in my head. When I plug that in, that's going to be about 32.1. Right? We're just rounding. Yeah, 32.14285714285714285. Okay, so whatever. It's about 32.1. So now, you may or may not have seen this form before, but it's called point slope form. Does that sound familiar? Maybe, maybe not. Okay. So this is what point slope form looks like. So if you don't have this, you're probably going to want to type it in or write it down on your notes. I guess what I should go with. I don't know why I said type. Write down in your notes, y minus y1 equals m parentheses x minus x1. So remember, let's see, what do all these things represent? So x1 and y1 is just an ordered pair. It's a point that is on my line. So the x1, y1 represents a point on my line. And then the m represents the slope. M is almost always used as slope. So we just used the slope formula, and we found that the slope was about 32.1. So I know the slope of my line. Now, do I have a point that my line goes through? I do. If you'll remember, back here we started with 2 points. I had the point 2, 50, and I had the point 16, 500. I can use either one of those points as my x1, y1. I would recommend choosing the smaller one because it's going to make the numbers a little bit easier to work with. So I would choose the point 250 as my point. So now I have a point at 250, and I know the slope is 32.1. So I'm going to plug those into the point slope form of a line. So that is y minus y1 is 50 equals m, which is 32.1, times x minus x1, which is 2. Any questions so far? So this is in what we call point slope form. Now, we normally like to talk about things in slope intercept form. So the way that we change from point slope to slope intercept is we're going to distribute over here. So this becomes 32.1x minus 64.2. And then we're going to get rid of this subtracting 50 by adding 50. So that tells me y equals 32.1x minus 14.2. That would be the equation for my line of best fit. So let's pick 2 points. So which 2 points did we pick? Okay, 262 is not on that line, though. It's close to that line, but it's not on my line.
1 and 60. Yeah, 1 and 60.
Yeah, 1 and 60 is definitely a good point to pick. Okay.
6 and 68.
Yeah, that's not 68.
11 and 72.
That would be a fine one as well. 11 and 72 would work too. Okay, this point here was not 668. That was 666.
Well, you got 65, 66.
Okay, so it's on the point.
66.
So it's right on the. It is. It's right on this crosshair. But look, so this goes from 64. Skip 1, 68. So what are they counting by? They're counting by 2. So this is 64, 66, 68. So this point here, the y value is 66. The x value is 6.
What about
8. Okay, that's close. But like if you look, you see how it's a little above that crosshair.
Yeah, I can.
So you're going to get a close answer for the slope if you do that, but we want to look and see if our line has any places it exactly crosses those crosshairs. So like Grayson was saying, 1172 would also work.
What about 10 and 71?
No.
Land on the orange dots.
At 10, we're right here. So this value would be, it'd be close to 71, but I don't know it's exactly 71. So it's not great to pick. It could be, but it's not right on a crosshair. You understand what I'm saying? I like to pick the points that are on crosshairs because it makes me know I'm right. I've got no question.
It looks like, but just looking at it, if it's consensus count by twos, it looks like it would be right there.
Yeah, I agree it's close. That wouldn't be a bad number to use. Like, you're not way off. You didn't say 10 and 90, right? That'd be a terrible number to use. You're close, but we want to be as exact as possible. Yeah, that's not good. So, we've got 2 points. So, I picked the points 160 and 666. Now, you could have picked 11 and 72. That'd have been fine as well. But to me, those are the 3 best points to pick. So I would do y2 minus y1 over x2 minus x1. So when I do this math, that gives me the slope is equal to 6 over 5, which is 1.2. Six divided by 5. If you put that in your calculator. So you could leave it at 6 over 5, or you could make it 1.2. I don't care. Both are right. There's not one more right than the other. Okay, so now I know a point that my line goes through, and I know the slope of that line. So I'm going to put it in point slope form. Y minus y1 equals m times x minus x1. Now we distribute. So this would be y minus 60 equals 1.2x minus 1.2. And now I need to add 60. That's going to give me a value y equals 1.2x plus 58.8.